I'm Brian from GreenBug Energy, and I'm going to talk about this off-grid screw generator we've built for a customer. This unit is going to be shipping to New Zealand. It's a 1.5 kilowatt Archimedes screw. It's 0.8 meters in diameter. That's the diameter of the flighting. It's got a shaft that's 18 inches because the shaft's only available in inches, so I say it's in inches, even the OD's in meters. This unit is a permanent magnet generator. It's going to be connected to a inverter system that'll be charging batteries for this off-grid home. The unit will turn at 40 RPM. It takes 150 liters a second of water, and it'll be installed at a 26 degree angle. I can show you underneath the hood here. We've got a permanent magnet generator that is driven by the gearbox. The gearbox takes the slow speed from the screw and increases it to produce electricity. This is making 3-phase AC power. In front of the gearbox, we've also got the upper bearing. The upper bearing holds the entire thrust load of the screw and the water, so when this unit is installed on an angle, this bearing's taking all the weight hanging off of it from the screw and the force of the water in the bottom half of the screw.
So what head is this designed for?
This is designed for 3 meters of head.
So does this, how expensive would something like this be?
This is a very costly way of being off-grid. This unit is about just slightly under 30,000 Canadian. And that's just for the Archimedes screw itself. You've got the cost of the gearbox on top of that and the generators on top of that, as well as plus the electrical control. So for a complete system like this without installation, you're looking at about 60,000 Canadian.
So why would someone do that?
Somebody would do that in situations where it doesn't make economical sense to bring in grid power, or you just simply want to be green, you want to be off-grid, you've got a water resource. $60,000 one-time investment with little maintenance costs over time could financially be better than the cost of, getting your hydro connected for free from your utility if you didn't have to bring in blinds and paying a monthly bill.
So does it sounds like it's very expensive if it's small. What happens as it gets bigger?
As the system size increases, the cost per kilowatt drastically decreases. So for example, the cost per kilowatt on this thing, once it's fully installed, could be around 50,000 a kilowatt. But if you got to a system that was 250 kilowatts in size, you could be down to about 6,000 or 8,000 a kilowatt, maybe better.
So it wouldn't cost much more to make this a little bit bigger, really?
No, to make this screw that's 0.8 meters in diameter, to make a screw that was 1.2 or 1.4 meters in diameter, the labor is effectively the same amount. Your fixed cost of materials increases slightly, so there's real economies to making a larger screw than a small one.
But you're pretty much stuck with the water source you have, though.
Yeah, unfortunately what you're stuck with is the water source you have and the amount of power you need. In this case, they have more water and head than they actually need. So we're just using a portion of the head and flow that's available. We're using 3 out of the 6 meters. And we're using 150 liters a second, and they've got a minimum end of summer dry flow around 300 liters a second. So this screw will be able to run wide open all the time at 150 liters a second.
Okay, great. Thanks.